Welcome to my new video, folks. It has been a while, not had time to do many videos, but in this video I'm going to show you how to build this 2.5 watt, well, call it a 2 watt transmitter with the potential to have an RF power of over 5 watts with just changing the output transistor. Well, in this video I'm going to show you how to build this. It's running into a double load at the moment, so it's all legal. Simple to build, cheap parts, ready and available, so no problem getting hold of the parts. Built on plain copper board, so no edging or nothing, you know, easy enough to do. Got an RF detector here, that's your power LED, and 2 audio meters here, VU meters, which look quite smart, don't they? Aye. So a lovely looking transmitter in it, really. Just a small disclaimer, this video is for educational use only. Please check your local authority laws concerning the legalities of using any type of transmitter, especially these FM transmitters that are broadcast on radio frequencies. If you do use one of these, please run into a dummy load like this. This won't even reach your neighbour's house when this is on. A 1 watt load going into this, it goes a matter of feet. So I'll never run one into an antenna. That's against the law. Just like to say as well, I do sound, you know, a bit strange in this video because I'm all blocked up. My left and right nostrils completely blocked. So I'm just waiting for an appointment for that. Should we get on with the video? Fancy your own radio station? Broadcast around your house, around your yard. Audio input, if you don't know how these work. Audio input from your phone, straight to the transmitter, through the antenna, and broadcast to your radio. Your own radio station. And I'll show you how to build it. Let's just run through a few of the stages of this transmitter. Very simple. Don't be intimidated by it. It's a very simple design. I mean, extremely simple. You've got your pre-emphasis, your audio input here, and that's obviously fed into the oscillator. That's your oscillator stage here. You've got a common mode choke here, plus a cap. That helps with noise in some switch mode power supplies. This is running through a very clean linear, so no worries there. Your oscillator stage, that goes through your first RF amplifier stage. This is the transistor here, very simple circuit. That exits and that goes into the last RF, the output stage here, which is the clone of a 2N4427 Motorola transistor. I think they stopped making these a while ago, but these clones, these are pretty good. And it goes through the low pass filter then, for its tuning stage here. Blue LED is obviously power, and the red LED is a visual way of knowing that a transmitter's got an RF output, and also you can peak it. I'll lower this voltage now, see how dull it gets. If I can knock this out just by spinning this cap, there you go. I didn't have it peaked actually myself. Wow. Right. Get it to, oh, sorry about that. That's it. Let's turn the voltage back up, that's it. Peak the circuit. And obviously you've got your meters here, your 2 RF, it's a mono transmitter obviously, but I've got these VU meters rigged in. I've got left and right channel. Just looks smarter with 2, doesn't it, really? Could just put the 1 in and combine the inputs, but it looks a lot better, doesn't it, with the 2. You'd think it was a stereo transmitter, wouldn't you? But I know you need ICs and that for that. a lot more complicated. Okay folks, should we have a quick look at the parts? Look at them beautiful meters. These nice for you audio meters. Sell these on eBay, sold loads of them. Great, very reliable. And they work well, they do the job. That's the RF detector meter circuit. A couple of diodes, LED. 3 caps. Heatsink for the final stage for the 2N4427 power transistor. These are marked up as Motorola, but definitely not made by Motorola. These are made in China. These are copies, clones, whatever you want to call them. But these work great. I've had loads of these. I've tested a lot of these in batches and consistent results. And you can get well over 2 watt output. So they do work well, and they don't get hot either. I can't moan at them for the price, the pennies. And the other 2 transistors here. One's for the oscillator or tank circuit, and the other one's a preamp, which will feed the power, which feeds the RF to the final. And these are PN3569s. You can still get them ready available as your resistors. BNC RF connector. 3 caps, 2 for the 1 for the power supply rail, 2 for the audio input. These are RF chokes. Coils. That's 3 here. The low pass filter. One's for the transistor. And one's for the tank circuit here. 4-turn coil. Easy to make. And here's the common mode choke. You can build this without this if you got a nice clean power supply. There's some switch mode power supplies quite noisy. This will just filter out some of the noise. But I do recommend you use one of these. Easy enough to. If you've got a linear power supply, happy days. Here's our Marconi air capacitor. These are great. I think these are ex-military. I've got a load of these. No, about 15 of these. Very nice. This is a variable cap. Made by Panasonic. There's all your caps. Your capacitors there, ceramic capacitors. There's your little islands which I've cut. These are my my diamond cutting saw. They're double-sided, so you get a nice earth. Oh, excuse me. No, it's a bit blocked. But that's all the parts, folks. Easy to get hold of. Easy to obtain. And cheap. Should we build it? Before you start asking, because I get it on all these transmitter videos, how far does it go? Well, it depends on a lot of things, doesn't it? Depends on what wattage you got it on, how well you are, how well your antenna is off the ground, what type of antenna, is your antenna tuned to the frequency you're on. This in the open with a tuned antenna, 30, 40, 50 foot off the floor, easily a few miles, 3, 4, 5 miles or more. In the city a lot less, obviously with buildings and that like, and pollution in there and what like, but generally a few miles in the open. Not bad for a little transmitter like this. All these parts very easy to obtain. The output transistor, the 2N4427, they're all clones, copies, pennies on eBay. These meters, audio meters, VU meters, cheap enough, very cheap. Power connector, cheap. Audio connector, cheap. The only part you won't get is this variable capacitor, trimmer, whatever you want to call them. And these are fancy ones. These are ex-military, I think. But what you can use is just a simple small one like this. Now I would use a Moretta if you can get them, or even Sun. I think it's called Suntan, some Chinese company, but some of these ones I've had off AliExpress, honestly, you turn them 3 or 4 times and they collapse. So try and get decent quality ones. So this one here, this is a Panasonic. These are extremely good. Yeah, so always go for branded trimmers or variable capacitors. Try and avoid the cheap China ones. Should we build it, folks? There's our copper board. What we'll do now, I'll just cut this into little squares, little islands. The gemstone cutter, you see this in a lot of my videos. Great cutter this is. That's enough, folks. Right, just give the board a quick rub. Does really help with soldering. Okay folks, first thing we're going to install is the positive rail, the common mode choke, 100 NF cap, 2 little islands to isolate the power. Okay, super glue the first island on. Oh, there's a bit too much on there, isn't there? Never mind, it'll dry. Next one. Let's just isolate it so you can actually put in the common mode choke. What do you need when you solder? You always use flux because it doesn't help with soldering, so plenty of flux. I like to put plenty of solder on, so please don't whinge at me in the comments. That's it with the flux. I use a lot of flux, but just make sure you clean it off afterwards, you know, when you're finished. I solder the one side with the DC connector in. Lovely. The other side. Use plenty. Doesn't have harm, does it, eh? That's the connector done. That looks good, doesn't it? $100 NF. Lovely. Okay, that's the DC connector in and the 100 NF cap. Next thing is the positive power rail, which we will put about there. A bit of glue, not too much. With the light I can hardly see how much I'm putting on now. Not a lot, just enough. Right, place that on. I reckon about there, hopefully. That's it, that's glued well down. Next, this is 220 UF 50 volt cap. It does say in the diagram here 470, but I couldn't find them, so 220 is good. Let's get that in next. Next is the audio connector, cheap off eBay. Well, these about 30-40p, stereo, but obviously a mono transmitter. We'll super glue that down. Go right on the end of the board. We'll super glue it and secure them with a bit of solder. Glue. What do I do with this? Stick that down about there. Now, because this connector is going to have a lead put in it, it will need some strength. I mean, super glue is just not going to hold it. So what I'll do, I'll use the legs of a thick capacitor and put it across here, across the ground pin, and secure both sides. Some solder down each side. There you go. Let's get one on the other side. What we're going to do now, folks, is install the common mode choke. As you can see here, put some solder down on these pads. Let's bend the legs and get it in. Just going to shorten these legs just a little. Okay, let's get this common mode choke in. Put the positive side in first. Straight on out. That's lovely. Let's do the input of the positive side. There you go. Output of the ground side. What we need to do is just install a little jump wire from the input of the ground side. That's it. That's it, just input of the ground side. Just say that. Common mode choking, your 100 NF cap, and obviously your DC connector. Looking great. Right, the next stage is the audio input stage, the first stage. So I'm going to put these two little islands in. Drop a super glue, not too much. There we go. Now the first stage of this audio input is these two 47k resistors plus two 1NF caps. This is part of the pre-emphasis system. This helps with the sound quality, it helps reduce noise and stops distortion. Could wrap the capacitor around the resistor like so. So it looks something like that. That's the two done. So just put a bit of solder along. Let's cut the leads. We don't need them this long. Right, let's install these. That's them installed. Install these how you like. Put another little hole into the middle, you'll see why in a minute. Just make sure you don't get them too close. Next, 2 more capacitors. There we are. Looking good. Let's install another island. A lot of components go to this one. It should be a bit wider, but we should be good. Next is the 22k resistor. This goes here in the circuit. I'll show you on the diagram where that goes. Just at the other end, I've just bent the caps out of the way. Just get in there. That's all in. Looking good, folks. Okay, let's install this big island. This is where the variable cap goes and various other components. Now you've got to get this pretty accurate, this one. Hopefully about there. Remember, you can't use too much flux. Okay, next is these 2 1NF capacitors. I'll show you in the circuit where these go. Let's install the first one. It is a bit of a gap, but it doesn't cause any issues. Get some solder down on the ground for the next one. Now it's quite difficult building these and filming at the same time, but it can be done. Okay, next is this 39k resistor. I'll show you where this goes, folks. Okay, let's get this 39k resistor in. Easy. Okay, looking good at it. You see that? Hopefully the light's good enough. Next is this variable Marconi tuning capacitor. These are great, aren't they? What I'm going to do is just fold the leg round, because I don't need it that long. That's it. They're trimmed, a bit more compact. I do encourage people to, to build these, I don't encourage people to use illegal transmitters, but you can put it into double load like I do. You do no harm. Good fun. Use it as an house transmitter, can't you? Now let's get this in place. I should be good about right there. Okay, solder in the back. Lovely. Don't know, it looks smart, eh? Let's make sure it turns actually. Oh yeah. Very good. Get some solder down. This bit here now is part of the tank circuit. It's the oscillating circuit. So I need to install a coil and a capacitor here. Okay, here's a 4-turn coil and a 10pf capacitor. When you do make your own coils, when installing them, make sure you scrape off all the enamel. It can be a pain if you don't. Let's get the other side of the coil. Lovely. Just put a bit more solder on both sides of that coil, just to make sure it's soldered in proper. 10pf next. You can't see it, but the markings on this cap, they're quite small, but always get them facing. Most convenient for you if you get any issues with it. You'll need to check your parts, make sure you've got the right parts at the right places. So have them facing you if you can. Looking good. Okay, we're going to install our first transistor. This is part of the tank circuit, the oscillator. This is a PN3569. Let's just trim the leads slightly. Just get a bit of solder in the corner here. That's it. Let's install it. We have got a resistor on the emitter side, so we'll do that after. That's it. Let's just do the collector side first. I don't know if you can see that, hopefully you can. Collector soldered in. Let's do the base. Get it round. Now the emitter leg I'll cut short because we are putting a resistor in now. Okay, this is the 180 ohm resistor. Let's install it, folks. Don't be afraid to have a go and do one of these yourself. Don't look, watch this video and think, oh my god, I can't do that. Of course you can. I'm only an amateur myself, far from an expert. I see, I just tidied that up a bit off camera, but there's a transistor installed. Okay folks, before we do any more, let's go to show you what some of these parts are. This is simply the preamp for this system. This is for the audio input. Have a look online. I'll show you bits of what the circuit does. I can't show you all, because you know, you should learn a bit yourself. But this is straightforward, this audio input. Please learn about it. Anyway, the art of this transmitter is this oscillator. This is what makes the whole the old circuit, you know, the old transmitter tick, basically. This is a Colpitts oscillator. I think this design, this sort of similar design, has been around since 1918. I think it was designed by, I don't know, was it Canadian, American Canadian? I can't remember. But it's been around a long time. It's basically a tank circuit. So the tank circuit would be this 4-turn coil and these two capacitors. Obviously this is a variable capacitor, and that is the art of it, the tank circuit. Like I said earlier, this Colpitts oscillator is made up of the tank circuit, which is capacitor and an inductor. Well, obviously there's a variable capacitor here. They both store and release energy. So it goes back, forth, back, forth, back, forth. Now, this would run out of energy because of the resistance pretty quick. So it needs an injection of energy, which I'll get from a transistor. So basically it will need a feedback capacitor, which will go across the collector and the emitter and the collector of this transistor. So that feedback capacitor is extremely important. So like I said, the next part I'm going to install is this capacitor, 20p capacitor that goes across the collector and the emitter of this first transistor. And obviously this is the feedback path that keeps the transistor oscillating and keeps energy being fed into the tank circuit. Now these Colpitts oscillators, they're used widely in RF communication systems, signal generators, electronic testing equipment, and obviously very simple circuits like this, you know, very simple FM transmitter builds. But it's a simple circuit but very effective, and this is an extremely stable transmitter. I'll show you at the end of this video, but you'd be amazed how stable this is. Okay, this is the important feedback capacitor that goes across the emitter and collector. That keeps the circuit working. You take this out of the circuit and the transmitter won't function at all. Let's put a bit of solder here. I could have put this on before the transistor, but I didn't. Hopefully you can see this, because it is a bit not exactly bright here, but it's quite awkward to do this. Let's get the collector side in first. Think we got it? Yeah, we have, folks. You can see that, I've just put the leg over the transistor and we should get it all in one now. Lovely. There we go. Looking good. Okay, next we're going to install another island. This will be for the output of the oscillator stage. Also, that'll be the base of the first amplifier, and also we'll have the resistor as well. That switches on the amplifier. Okay. Hopefully my hands are not in the way too much, folks. There we go. Get a bit of solder on this. What you can do is put the super glue on there, glue it down with the super glue, straight away put the solder on top. That'll soon make it stick with the heat. Looking great. A bit of solder here. Okay, I've cut the legs. Here's the next part, the 20pf, the output of the oscillator into the base of the transistor for the amplifier. Let's install it now. There we go. Getting there, folks. Okay, next is the first RF amplifier. It's the second transistor to be installed. It's the PM3569. Great transistors these are. That's an RF choke. That's the resistor there to turn it on. And that's the output capacitor at 20pf. I think we might need a Highland or two. We'll get them. Let's install it up. Okay, I've done a couple of these, so I sort of know where to put these, so makes it easier for you. There's that one. And this one goes about, just how about there. Look at the glue popping on it. But these stay down, they never come off. Right, this is the 22k. I'll show you in the circuit where this goes. There you go, folks. Yep, the other end. Remember with these coils, get all the enamel off, because it makes soldering a lot easier. There you go. All the enamel, it scrapes off. Just put a drop of it of flux on. You can tin it before we install it, just makes it a bit easier. Put the other side in. That's installed. Okay, we'll install the second transistor now. I've checked to make sure it's the right one. It certainly is. Okay, legs cut to size. Let's just drop it on. Let's do the emitter size first. Collector, the base. It's in. Now, you might have noticed the emitter side is going nowhere, is it? It's going to the island, but where's it going? I'll put it on an island. It is going to ground. The emitter obviously goes to ground, so what I'll do, I'll just put a link in here straight to ground. Just to, you know, in future, in case I need to do any modifications to the circuit. At least we have an option then, doesn't it? It's all the same out then, isn't it? Looks a bit neater. Okay, next island is going to the output of the first amplifier, and that'll be the base of the last output stage, the last transistor. Okay, the last component of the first amplifier stage is this 20 PF capacitor. Let's get it in. Just spun that round so you can see where we're soldering. There we go. Right. Should we test the amplifier now? No, it's looking good. The oscillator on the RF amplifier comes up. Oh, on the audio input obviously. But we're getting there. It's alright, isn't it? You can do one of these yourself. Highly recommended. Okay, next we're going to test this RF amplifier. See how well it works. It should work well. What I'm going to do is connect up this BNC female RF connector directly to the output, right there somewhere, and we'll use this high quality RF lead to the meter. I'll use a couple of RF meters so we can get an accurate reading. So should we get it tested? There you go. Let's get the meter connected up. There we go, got the RF meter connected up. I love that meter. Okay, I've got that set 3 volts. Here we go. That's drawing a bit of current. No loss. Well, 3 volts. I've got about 21 milliwatt. That's amazing. That is pretty good. Doesn't sound much, but it is. I'll put it on 5 volts. That ain't bad at all. 5 volts. Actually, I'm sure this will go down. Let's go down. 2 volts. Look at that, 2 volts. The oscillator still works, and we've got like 9 milliwatts. That's on 2 volts. Alright, let's take it up to 10. That's not even warm. Wow, look at that. 10 volts. That's a bit more than I thought actually. If we look at the data sheet for this 2M4427, I think we're going to get 2.5 watts out of that. Let's go up 2 more. 12 volts. No, we're maxed. That's quite amazing. Now that would get us slightly warm, I would have thought. Not at all. The oscillator. That never gets warm. Very low current. Now that is amazing. That is more than enough to feed the output stage. Wow. 9 volts. Happy days. That's it. Should we build the last amplifier stage now? I think we're easily going to get 2.5 watts out of this. Okay, just going to connect it up to my other meter. This is the this goes up to 150 watts. So it's on a 5 watt scale at the moment. Top one. Try 5 volts. Yep. there, about 60 milliwatts. Let's put it up to 12 because we was getting about 250, weren't we? 250 milliwatts. Let's see what we got on there then. If you look at that, that is bang on 250 milliwatts. So we know that's the output of that first stage. 250 milliwatts. It doesn't even get warm. No, slightly warm. Great, that is. That's definitely going to drive the final transistor to about 2.5 watts. That's not doing too bad, is it? 250 milliwatts. That is pretty good. But what frequency is it on? Have a look. You see the other radio stations just to the right. But you can see this one's a lot higher because it's right next to it. So it's 88.5 megahertz. We'll test the frequency at the end of the video anyway. We'll go right through its frequency range and we'll see whereabouts it is. Next to install is this 100 NF and 1 NF capacitor. I go up here in the circuit. I think in the end I'm just going to cover this positive rail with solder. Whenever working with RF circuits, just cut leads as short as possible. We have got some long leads on here, but we can't help it with this type of board. The last transistor. This is the fake, or whatever you want to call it, clone 2N4427. These are good. These do work well for what they are and what you pay for them. Got two RF chokes there, two capacitors, 100 NF and 1 NF. I'll call that 1, 2, 3, 4, 5, 6, 7 turns. I'll give you all the dimensions of these after. And my 33p cap, that's the output to the low pass filter. Should we get it installed? Okay, we'll install this choke. What I'll do, put some solder down here on the ground for the 100 and 1 NF capacitor. Tell you what, building circuits like this is very satisfying, very easy to build. So, think I might call this a 7-turn coil earlier. Oh, it's a 6-turn. So we'll just gotta bend the legs a bit like that. Bit of flux and solder before we install it. It's quite a thick coil. Let's get the 6-turn coil in. Lovely. Well, next is one of these clone, fake, whatever you want to call them, copies of the 2N4427. I've used a lot of these. When I first bought them I thought they ain't going to be any good, but they do work. They're quite consistent as well. There's a pack of them there. You get good results with them. So I can't moan for the money I pay for them. Let's get that in next. Just trim the legs. Just a little bit. Hopefully you can see this okay. Here's the base. Just go over that emitter again. Emit side. It'll be a bit awkward seeing the collector side. Filming this and trying to do this. Wow, it's hard. But it's in. Okay, you might have worked out that the emitter side here doesn't go to ground, does it? Because it's on the little island, so I'll do what I did before. Just put a link over. Okay, we need a small little island for the output of the final transistor. I'll just put a little 33 PF capacitor on there. Now let's install this 33 PF, the output. Hope you can see this. It's a bit tight getting in here. There we go. Next I'm going to install this variable capacitor. This is made by Panasonic. I got this off eBay. This is a 6 to 50 PF adjustable trimmer. Now these are wonderful. Made by Panasonic, like I say. Now please avoid buying cheap China ones because they are useless, honestly. Try and buy Moretta ones, you can still get them. Or even Suntan, make half decent ones, but you can get some rubbish off eBay, so just be careful. Okay, so get some solder, because obviously this trimmer goes to ground, so about here somewhere. Oh, should we solder in the Panasonic trimmer? You'll see a bit later on what this trimmer does. This just fine tunes the output. It makes a huge difference. Right, get in there, innit? Just got the low pass filter now. Looking good. You can build this yourself, honestly. I'm no expert, far from it. I almost forgot this choke. Goes from base to ground. Well, let's get this choke in. It's an RF choke. But you can see a bit better now. There we go. See how close the marlins are. I've checked, they're not touching. Lovely. Okay, not much left now. Got the low pass filter here. 3 coils, 3 turn coils, 3 capacitors. Got an adjustable one here. This cleans up the harmonics, because if you transmit on 100 megahertz, you're gonna get you know, an output also on 200, 300, 400 megahertz. So this filters that out. Just get the islands in now for the low pass filter. In. Okay, second core of the low pass filter. Right, the last core of the low pass filter. Okay, it's just solder in the middle now. Get them in completely. Lovely. That's it. Just got the capacitors now. (20 PF). I'll show you on the circuit where this goes. Next one's is 50 PF, which goes here on the circuit. Okay, the last capacitor of the low pass filter is a 20 PF. Happy days. That's a low pass filter. Completely done. Looking good. Okay, now is the BNC RF connector. Let's get that installed. Okay, should we install this RF connector? That's that installed. Just got to connect the RF output now. We're almost ready to test. There we go. That's the output connected. Not too much left now. Got the RF meter and the two VU meters, the audio LED displays. This comes, well, the next circuit is going to be LED RF power meter. This is a very useful tool to let you know if the transmitter, oscillator and amplifier stages are working together. It's simply basically a simple circuit really. You've rectified the RF and loading up a capacitor and lighting up an LED, and it's a very useful circuit. This RF meter will give you a quick visual way to check how much power has been transmitted. It normally illuminates about 450 milliwatt, so once you've got a bright LED you know you've got near enough half a watt. And also you can tune and peak the circuit for maximum RF power. You've got one tuning stage on this, which is at the beginning of the low pass filter. So when you adjust the tuning capacitor, this changes the brightness of the LED. So obviously the brighter the LED, the more RF going out your final stage, your final transistor. Yep, so basically this is an inexpensive RF meter. RF power meters can be expensive, they ain't cheap. On this transmitter we'll have one built in, so you can use it obviously to diagnose any issues with the transmitter and to peak its RF output. So basically if the light's nice and bright, your transmitter is happy. Should we build it? Oh, this is the parts, right many. There they are. We'll put the one NF in between the two diodes, just like this. So this is the input cap, the 1NF. We've got two of them. Split the legs, we're ready for the LED. Okay, just make sure you get the LED the right way around, because it won't work. That's an extremely simple circuit to build. Okay, just the 3.3 pf capacitor now. This is the cap that goes to ground. That's extremely important. You need this as close as possible. Others are not too critical, but this you really need it about 3.3, otherwise it will affect the circuit. Right, the last part. There we go, there's our RF detector, or RF meter, whatever you want to call it. All complete. Shall we have a look at it? Lovely. Should we install it? Okay, let's do the capacitor now to ground, which is out. That's that installed now. We're just going to bend it into shape now and put it exactly where we want it. Looking good. Let's have a look. The audio input stage, the oscillator, tank circuit, the rest of the oscillator. To the right there is your first RF amplifier stage, and the second, and the tuning cap, the low pass filter, and we've just installed this, the RF power indicator. It's a great little LED this is. This tells you so much about the circuit, and it's self-powered. Obviously it powers itself from the RF energy. Give out a bit of that to a little DC voltage and powers up the LED. Don't need a current limiting resistor, because I don't even think it gets to 10 milliamp. But what am I saying now? Next we're going to install the power LED. Nice blue LED here with a 3.3 kilo-ohm resistor. It's a bit high, but we don't know what voltages we're going to go up to on this. Should we install that next? Bend it to shape where we want it. Let's have a look what the RF LED and power LED look like. There they are. RF LED. And the blue light for your power. Looking good. What we'll do next is plug it in, because we've got a lot to test. We haven't tested that final stage here. We ain't tested the low pass filter. We've got a lot to test on that anyway. I won't make sure it all works. What we'll do, we'll plug it into the RF meter, test it all. Once we're satisfied with the RF output, the next stage will be these VM audio meters. They're going on the front here somewhere. I'll stand them up like so. On there, on there. Well, that'll be last, so we'll do that at the end. Looking good. The final output hasn't got its heat sink on yet, but we'll do that at the end. Actually, we'll do that next, so I'll need that on for it to be tested. Now, we're all ready for the big test. Rigged up to the watt meter, and I've rigged up my different power supply this time. This is a linear one, much quieter, much cleaner DC power supply. I think it's the 1 amp. Let's get enough of these. Before we do anything, we're going to need to put the heatsink on, because This final stage would burn out in no time without a neat sink. I get pretty warm to touch, but over time, you know, it'll soon get very hot. Alright then, should we turn it on? Fingers crossed. We've got nothing at the moment, have we? We've got no voltage. Let's turn it up to about 5 volts. Oh, that LED ain't lit yet. That's not good. I've got about 160 milliwatts. Let's try and tune it. It must be way out. So I'll get that in one shot. Oh, that's better. Way out of tune. Oh no, the LED's lit up a bit. Cool. Should we take it to about 10 volts? Oh, that red RF detector now is well lit. There we go. Over 1.5 volts. Volts. Over 1.5 watts. That is great. For a cheap Chinese 2N4427 transistor. It does its job. It works. Should we give it about 15 volts? I ain't going to go much more on that at the moment. Oh yeah, nearly 2 watts. Not bad at all. Not bad at all. See how bright that red LED is, eh? We've got a good wattage there. That's so much frequency we're on. 88. 88.9. Not bad. Let's get them VU meters in. Oh, back again. Before we install these beautiful audio meters, I'm not happy with one or two little things. Firstly, you see that wire there from the low pass filter to the BNC connector. It's very thin. I'm going to use some of this. Same stuff I use to make the coils. Just look a lot better on it. And also, the 4-turn coil in the oscillator, the tank circuit, I'm going to replace as well with this. And I might add an extra turn, so I'll put that 5-turn coil in. I'll just lower the frequency slightly. So we'll do them 2 little mods. But this is the old wire. I made the coil with 4-turn coil. That was 0.55mm, so that'll work fine. But I'm going to use this thicker stuff, which is, what's that, 102mm, 103mm. So let's get them 2 things done. Gotta admit, that looks a bit better, doesn't it? Yeah, that's better. Big improvement. Next, take out this 4-turn coil and replace it. Let's get this out, shall we? Okay, Making this coil could not be easier. Got a 3mm drill bit here, so make sure you got enough of the leg. So you always just, you know, go a bit over slightly. But there's one turn already. 2, 3, 4, 5. Easy as that. So just straighten it out with a pair of pliers. Just makes getting the enamel off a lot easier. There we go. Looks a lot better, doesn't it? Great. Okay, should we see how good these Chinese 2N4427 transistors are? Right, we're on 81 megahertz, 81.4 megahertz. Obviously you're going to pick that up with the radio, are you? Just below the FM radio band. 81 megahertz, we're on 6 volts. Should we whack it up? 12.5 volt. 2 watt. That's not bad, is it? Should we give it 15? Oh, 15.6. 2.5 watts. That ain't bad, is it? Alright, should we see its frequency range? This will be given to a friend in Australia who's had one of these for a couple of years, almost identical to this, and he's had it on nearly every day. Never let him down. They are super reliable for what they are. We're on what we're on there, 86.4 megahertz, okay. Obviously putting this screwdriver on, it's metal, so it's going to adjust it slightly, but should we go along? 87. It stands way above the other radio stations for obvious reasons. We're right next to the transmitter. 89, there's 90 megahertz. 95, 96, 97, 98. There's 100 megahertz. 104, 105, 106. I think it does the whole lot. Oh, is it 10? Yeah. Stops about there, really. 107.9. That's good enough. Because this is a double-sided board, I'm going to stitch them together. I'm going to drill some holes in this board and just loop through some wire and solder them together. Because the more ground surface you've got with these, the more stable they are. These are super stable. You can touch any part of this circuit virtually. Put your hand all over this. I'll show you at the end how stable they are. They're super stable. And because I use a power supply, not batteries, I stay bang on frequency. Anyway, should we stitch the boards together? Do not breathe this dust in, please. Be careful. This fiberglass. I'm going to need a smaller drill bit. I've got a smaller drill bit now, 0.25 mil. Let's just feed these through. What I'm going to do is just put 4 on, well, 1 in each corner as well. Only small ones, I don't want them looking messy or anything. Well, it's 3 corners. I've got the power connector in the one. Fold it round. Fold it round. Now we've got great grounding now to the bottom layer now. That's it now, we've got a lot of ground on this little circuit. What I have got, some of these stick on little feet, so what I'll do, these stick well as well. I might as well put a few of them down. There we go. That's got 6 feet now. Lovely. Alright then, we're almost there now. We're just going to install these meters now, these audio meters, which we'll be going about there. To install them, we're going to put these in, so they're stealth. I'll run the wires underneath. I don't want them going across the top of the board and spoiling the look of the board, so what I'll do, I'll wire them from underneath and just drill through the board and pull the wires through. So install them. I've got an idea how to mount these. Right, this is an early prototype I did, and you can see I've glued these in. Look at that, looks a mess, doesn't it? But that was an early one. So I used an 8 gun, but looks a mess, doesn't it? Got a good idea. 2 middle pins there are the ground pins, just there. 2 middle ones are ground pins there. So what I'm going to do is use some of this thick copper cable. It's really strong stuff, this. I just soldered the 2 grounds together, come off, and then connect to this board. So then we'll stand them up then, and we'll do the wires underneath. You got 2 left and right channels. Obviously these are going to be earthed, so we don't need to worry about the earth wire. On the positive, we'll just draw straight for this board. So give it a go. Yeah, something like that. Well, that's about right. It needs a lot less than I thought, but let's get the other one just like that then. That's both the supports on there, on there. Well, I've got to wire both of these positives together. So what I'll do, I'll just use a bit of glue and glue them both together. It's going to make installing them a lot easier. Just put a bit on the back. Here's a little jump wire. It's going to be the positive from here to here. Then we'll just have one coming in, then the power feeding both. Well, I've got this heat gun out, so I might as well just fill the middle of these out. So you get no movement in the coil at all when temperature changes. Oh, that's too much in there. To clean that up. I've cleaned up a bit. Well, let's put the jump wire across for the positive. Yeah, let's connect the other side. Lovely. There we go. Join together. So there's the power. Good on it. There we go. Looks a lot neater, doesn't it? You see how that's going to stand up now, look, with these legs. Just at that angle. It looks good. So this will be going about there, I think. What I've got here is a bit of enamel wire. That'll be for the positive feed. Alright, just going to wire in our left and right channel audio input. You can see here, it says in. Hopefully you can see that. In. So we've got left and right obviously. This is 2 channel. It is now. Let's get this side in here. Can we just see it here? It's going to be quite tight because there's some glue right next to it. There we go. Okay, let's get the other audio input soldered in. There we go. So very easy to install these VU meters. There's nothing to them, is there? You got your left and right audio in, your ground obviously, and your positive. Simple as that. They're ready to install. What we're going to do now is just build up some solder where the mounting points are going to be. So I think I'm correct about here. Just got to build this up about 1/2 mil. I should do. And I think the other one was about here. I just want to lift it up slightly because the positive is right at the bottom and I don't want that earthing. Doing no shorts. Job done. What I'm going to do with this marker, I'm just going to mark out my drill holes for the power, left and right channel. I've just marked out. I'll be drilling here, left and right channel to come through for here, and power over here. So 1, 2, 3, 4, 5, 6 holes. So all them done. That's it, all the holes done, all cleaned up. Just going to feed our wires through now. Positive. One of the channels. Should call it right channel. And the other channel, left channel. On the left side, isn't it? So just feed it all through. Okay, we've sort of got that in place now. We're just going to get ready to solder that down now. Should we try and get it in now? I want this leaning back at a nice angle. So let's give it a go. The other side in now, we've just gone slightly out. Hopefully it will line up. You know what, folks? I think that looks good. That's lined up pretty nice. See the back there, look, there's one support. There's the other one there. All good. I can take that bit of glue off the middle now. What I've got to do now is just re-brick these wires now underneath. Let's feed them through. Don't look too bad, does it? I use a bit of super glue. Tidy that up a bit. This one's the power to the meters. Let's just cut that there. Now sticking out here, we've just got our left and right channels. Now these got to be connected as soon as the audio comes in. No point doing it after this resistor. The sound level's too low. So we'll connect them immediately here. Scraping the enamel off there, very difficult indeed, but I think we've got it. You know what, we ain't got a lot left now, have we? We're getting there. Long video. Oh god, I think this is the last bit of soldering. Great. Quite a tidy job. Not bad for an amateur. See that meters in now, both of them. Just see the left and right side there coming through the arms. And obviously the power was just there on the left, in the middle of the screen. That's it, I'll just super glue them down a little bit. Bring it all looking good. Oh, we're all plugged in. We've got the RF going into this dummy load because we don't want to be broadcasting on our test because that is illegal. This going into dummy load won't even reach next door neighbours. I've tried. So I'm not going to be disturbing anyone. Let's go straight into a dummy load. So, not breaking the law. There's the audio input from my phone. I've got a radio here. And our power supply. Not using the switch mode. They're horrible and noisy. This is an old linear supply. Yes. Got blue and red lights. Cool. RF output. We are outputting just over 1 watt. Is it 1.1 watt? Not bad for that voltage. What's that? Less than 10 volts. Let's put the radio on. Cool, that looks good, doesn't it? Meters work well, and they look quite smart, don't they? Definitely. I like it. For a basic transmitter, it's got quite a decent sound. It's obviously mono. No ICs, is there? Just got the transistors coils, really. And obviously resistors and capacitors, but you know, for mono, get enough sound or else. Right. Funny actually, because look at the amp meter on there, look. Goes to the music, doesn't it? There's a little bit of current these meters do. Look at all the VU meter on it. Funny on it there. Brilliant. Turn the volume up on the phone, get into the red. That's quite a smart transmitter, isn't it, really? You've got to admit that. Very happy with that. How stable is this transmitter, should we say? Well, touch the earth, or ground, whatever you want to call it, no problem. RF output, yeah. Rock solid frequency. On the low pass filter, yeah, put my hand over that. Obviously any of that you can touch. Any of the input, no problem. centre amplifier. You can even touch that. It's amazing you can touch that without the frequency moving slightly, because the heat sink's connected to the actual collector side, not the emitter. I have got one of these identical to this, identical transmitter, but it's got a different output transistor, double the wattage, does 5 watts, and that's the heat sink's connected to the emitter side. Look at that, put my hand right over that. Look at that. Look, my finger then just touched the tank circuit. Obviously, if you touch the tank circuit, that's going to adjust the frequency. That's totally obvious. Even the coil. Yeah. Stable really, isn't it? The meters do look good, don't they? Can't exactly see what voltage this is running at. Looking at that. So I put my multimeter in. Just over a watt on it. 10.3 or 10.4 volts, should we say? Not bad at all, is it? Before we go, I was going to show you this transmitter. This is what the build was designed around. This is identical virtually. This was the original prototype. The only difference with this, two small differences: it's got a different output transistor and it's got a jumper. Can you just see the jumper there? That disables the VU meter, because I can take this up to 20 volts and these VU meter's got a maximum voltage of 16 volts. I've accidentally turned them up before and blew them, so if I pull this jumper out, they go off. Right, what's that on now? 9 volts. I'll show you the different. I mean, all the outputs the same, all the low pass filters the same, one tuning cap. It's all identical really, but this has got a lot more power. I will do a video, if you want the video, showing you what transistor this is. I ain't going to tell you. The only clue is it's got gold legs. The bottom of the transistor is gold, and it's Motorola. That's it. Right, you should turn that up. What voltage we got there? So let's try 12 volts. So 1 3/4 watt. Let's check the frequency actually. $89.4. So it's on 89.4 megahertz. Let's whack it up to 15 volt then. 15.8 volt. Oh, just doing over 3 watts. Just over 3 watts. So let's check it. I'm going to take it up to 20. Alright, what we got there? 18.8 volts, not even 19 volts. And we'll do 5 watts. So that transmitter I built in this YouTube video has got potential to go off my scale, 5 watts. It's on. Go out to around the back. We're out the back now. Sounds good, doesn't it? It's an edge transmitter with the potential, like my friend uses in Australia, he's in the outbacks. He goes miles and miles and miles with one of these. But his nearest neighbour's about 30 miles away. Just a quick one before somebody mentions it in the comments, no doubt they will. Because I'm filming it and, you know, a bit awkward and there's tools everywhere and whatever, so I didn't realise the soldering iron was filthy. I mean, I can see now when I'm looking back at video clips where I've been soldering and it's been leaving muck really from the soldering iron. But not to worry, because believe it or not, it will come off. So, I ain't too worried. Just give it a quick clean, get all the flux off too. So we'll clean it up, it will look a lot better. But I should have checked the soldering iron tip, because it was filthy. Never mind.